Okay, so what I want to do is show you guys a couple of or a few tricky integrals, and also some cases where we want to use the both parts of the fundamental theorem of calculus. So, well, try to think. Let's try to think. Which ones do we want to do? Well, why don't we start off with the integral of a piecewise function. So let's say we have a function that is equal to x when x is less than 2, and 1 over x if x is greater than or equal to 2. Okay. Well, and let's say we're trying to find the integral of this function from -5 to 5 of this function. Okay, well, since this is a piecewise function, and it's defined as a different function from two different intervals, well, I have to break it up somehow, right? Because, well, I'm going from -5 to 5, and my function breaks up and changes at 2. So, well, why don't I use the properties of integrals that say that I could break this up? So, can't I say, if I'm breaking it up at 2, because that's where it splits, I would break it up from -5 to 2. So then you look, okay, well, what function does it equal from -5 to 2? Is it x or 1 over x? Waiting for you to think. Think. You're right. It's equal to x. So from -5 to 2, we're going to find the integral of x dx. And then we're going to add the integral from 2, because you end right here, so we're going to go from 2 to 5. Because remember, these have to be the same. Now, what function does it equal from 2 to 5? Think. You're right. This one. 1 over x dx. And so now we can find the integral, right? Because, well, now we just use the fundamental theorem of calculus that says, when we're finding the definite integral, first, step 1, find the antiderivative. So this is fundamental theorem of calculus in English. Find the antiderivative, plug in. Step 2 is plug in top minus bottom. Wowza! So this is excellent. So the antiderivative of x, this one I just used the backwards power rule, right? Which is x squared over 2. And this is going to be evaluated from -5 to 2. Okay, and then plus the antiderivative of 1 over x. Here you have to be really careful because we can't use the power rule for this one. The antiderivative of 1 over x, remember, is just natural log of the absolute value of x. You got to be careful with that one. Also, another one, 1 over x is also equal to x to the -1, and so we got to keep that in mind too. So the antiderivative of 1 over x and also x to the -1, which is exactly the same, is natural log of the absolute value of x. And this is going to be evaluated from 2 to 5. Alright, so that was step 1 of the fundamental theorem of calculus. That's what we just did. Alright, step 2 says plug in top minus bottom. So we're going to plug in, we're going to do both. So we're going to do, this is equal to, top is 2, so I'm going to have 2 squared over 2 minus, make sure you put a parentheses. Actually, I should put a parentheses on this one too, just to make sure we don't make any mistakes. Minus 5 squared over 2. Okay, so this is the very first one. And then I'm going to do the same thing for the second one. I'm going to have natural log of, I don't really need the absolute value because these are both positives. But the absolute value, the natural log of 5 minus natural log of 2. And this was step 2 in the fundamental theorem of calculus. We plugged in top minus bottom. Okay, and so then this is equal to, well, we can simplify this quite a bit. This is 2 squared is 4 over 2 is 2. And then minus negative 5 squared is positive 25 over 2. So it's minus 25 over 2. And then plus natural log of 5 minus natural log of 2. And if we plug this into our calculator, we're going to get, this is about negative 9.58. And that's it. So this is how you find the integral of a piecewise function. You have to break it up into 2 and use whichever function it is that whichever function is defined on that specific interval. Okay, so that kind of leads us into our next type of integral, which is absolute values. And so let's say, for example, we want to find the integral from, let's say, 0 to 1 of 2x, the absolute value of 2x minus 7 dx. Okay, well, we don't have, just like for limits, we don't have a way to find absolute value of limits. I mean, limits of absolute values. We also don't have a way to find... Are you staring at my hand with ink all over it? That's what happens when you write with pen so much. Anyways, we also don't have a way to find the derivative of absolute value functions. In exactly the same way, we don't have the way to find integrals of absolute value functions. What do we do? What do we do? What do we do? What should we do? Think, 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 think. I'll let you guys think for a little bit. Think back to the problem that we just did. What do you guys think? Are you guys thinking to break it up? Wow, awesome. Okay, so this is the plan. Break it up into integrals using the definition, right? Because really, this is just the absolute value of 2x minus 7. It can be written as a piecewise function, right? And so remember that you need to find. So let's do a quick recap. Is that this guy? So recap, because you might have forgotten this. The absolute value of 2x minus 7 is equal to positive 2x minus 7 when 2x minus 7 when the inside is greater than 0. and it's equal to negative 2x minus 7 when 2x minus 7 is less than 0. And then remember that you can put the equals on whichever one of the two because it's going to be exactly the same. So we don't worry about that part. But what we need to do is figure out where this guy is going to be positive and where it's going to be negative. Okay, so then we can say that 2x minus 7, this is the definition of the absolute value, right? So this is equal to 2x minus 7 when, so let's solve this. If we solve this, we're going to get that x is greater than or equal to, if we bring the 7 over, we're going to get positive 7, and then divide by 2. So this is, it's 2x minus 7 when x is greater than or equal to 7 over 2. Aha, now it's going to be minus 2x minus 7. So if we distribute the negative sign, let's do that. That'll make it easier for us. Minus 2x turns into plus 7. Now let's solve this one. We're going to get x, if we bring the 7 over, it's going to be less than 7 over 2. Well, that makes sense, right? It's going to be the same number, just for one it's greater, the other one it's less. And so this is going to be minus 2x plus 7 when x is less than 7 over 2. And so then to find this integral, well, oh, that's not good. Well, that's silly. That's a, oh, okay, let me change this. Because, well, I don't know if you noticed this, but this problem is just no fun because 7 over 2, that's 3.5, and here we're only going from 0 to 1. So what I want to do is I want this number to be somewhere in the middle. So I'm going to change this problem. This, you guys are kind of used to this by now. And I never said I was perfect, right? So I'm going to change this to be the integral from 0 to 5. This makes the problem more fun. Of course, you can do it from 0 to 1, but no fun. No fun. We like fun. Okay, so, alright, back to the problem. So I use my definition, and then just like in the previous problem, we can break this up. So let me rewrite the problem. The integral from 0 to 5, absolute value of 2x minus 7 dx. This is equal to, we're going to break it up. Now, where do we break it up into? Right here at 7/2, right? So we're going to make an integral. One is going to be from 0 to 7 over 2. And which one of these two functions am I going to evaluate from 0 to 7 over 2? Well, which one is defined from 0 to 7 over 2? Well, that would have to be this first one, right? Because this one's valid when x is less than 7 over 2. So this one is negative 2x plus 7 dx. And then plus the integral from 7 over 2 all the way up to 5, which is my original endpoint. And this one I use whichever function is defined from 7 over 2 to 5, and that's going to be this first one, 2x minus 7 dx. Oh no, I'm okay. Sorry. I thought I made a mistake, but I didn't. Sorry about that. Didn't mean to alarm you. Okay, now. Well, now this is no problem, right? Because this I can do by breaking it up. See, this guy, smart guy, break it up. By breaking it up, now this allows me to find the antiderivative, no problem. So here, I'm going to have the antiderivative of negative 2x is negative 2x squared over 2 plus 7x. And this is going to be evaluated from 0 to 7 over 2. And notice that the 2's cancel. 2's. Okay. Anyways, then I'm going to have plus the antiderivative of 2x. Well, that's just going to be 2x squared over 2. Ooh, they cancel again. Minus 7x. And then this is going to be evaluated from 7/2 to 5. Almost done. Da-da-dun, da-da-dun, dun, dun, da-da-dun. Alright, so now we plug in. So we have here top minus bottom by the fundamental theorem of calculus. So we get minus 7/2 squared plus 7 times 7/2 minus, so this is the top, minus plug in the bottom. Notice that when I plug in the bottom, I'm just going to get 0. So I'm just going to save us a little bit of writing and just plug in 0. Because 0 plus 0, well, that's just 0, 0, 0, 0. Okay, now, that's the first one. Plus, now I'm going to plug in top minus bottom into this one. So this is going to be 5 squared. See, this is how my hands get all full of markers. See, I hold 2 and 1. I need to get better with this. I'm not very good holding 2. Oh, what about 3? Whoa. Anyways, I don't know what I'm doing. I'm getting delusional. Sorry about that. Okay, plug in 5. That's where I was. Plug in 5, so 5 squared minus 7 times 5. So this is top. Now this time it's not 0. So minus, so this is top, minus, plug in the bottom. So here, let me put parentheses here because parentheses are very important. You don't want to make any sign mistakes at this point because we did all this work and it would be a shame to just get it wrong right now because I didn't put in my parentheses. Okay, so now I'm going to plug in the bottom. So it's going to be 7/2 squared minus 7 times 7/2. Whew. Okay, now this guy is going to equal, if you do all this stuff, equal to 29 over 2. And that's as long as I didn't make any mistakes, which I don't think so, although I have been known to make them. So let's just hope that I made no silly mistakes. But if I did, well, it's your job to fix them. Okay, goodbye. Okay, now I'm happy. Because I just went back and I rechecked all my work, and it turns out that I did not make any mistakes whatsoever. So I'm going to give that 3 smiley faces to go. Okay, goodbye. Now for reals.